Hi, I'm Michelle Marshall, and this is my membrane concept map. I started off with the plasma membrane just because everything kind of falled off through the plasma membrane, and it was easier to make that my center point. First, I'm going to go ahead and talk about this because it is my shortest connection. First, I'm going to go ahead and say the sterols. They do contribute to the plasma membrane, and from the sterols, I did the steroids, which sterols are a type of steroids. They're like a subunit of steroids, so I went ahead and put those two together by themselves. Now, coming off to the left side, I did what helps explain the plasma membrane, which is your David and Daniel model. I went ahead and put this first just because it did originate first. And when I come down here, I went to the next model, which is your Singer and Nicholas model, which soon came after the David and Daniel model. So I went ahead and put those two together. Now, following the plasma membrane, I did what composed the plasma membrane, which is, of course, your proteins and your phospholipid bilayer. Now, starting with the phospholipid bilayer, I did what also composed the phospholipid bilayer, which are your glycolipids, and I went ahead and added the amphipathic to the phospholipid bilayer just because it does contain hydrophobic and hydrophilic at the same time. So I went ahead and just put it and helped make it up. And then, of course, I put your hydrophilic heads and your hydrophobic tail. Now, coming off the hydrophobic tail, I also put your saturated fatty acids and your unsaturated fatty acids because that is actually what does compose your hydrophobic tail. Coming back up to your proteins, with proteins, I went ahead and connected all the proteins, of course, to it, which is your integral proteins, your fibrillar proteins, your membrane proteins, and your glycoproteins, which glycoproteins also helps create the photoglycone, which is also part of protein as well in general. Coming off your membrane proteins, of course, I have connected all the examples that are part of it, which is your transparent membrane protein, your receptor membrane protein, your anchor membrane protein, enzyme membrane protein, monolayer associated membrane protein, your detergent molecules, your lipid-linked membrane associated protein, and your protein-attached membrane associated protein. Yes, I know there's a lot of them, but I went ahead and put them as a big list by themselves. Coming back to the membrane protein, I also connected the membrane channel, which helps create the ion channel, and it helps come down to the gated ion channel as well. Membrane protein also causes passive transport, and I went ahead and added active transport to the passive transport, even though it can be somewhere else in the graph. I just went ahead and put those two together just because they're usually seen together, and they are opposite of each other, so I thought it was best to put them next to each other and connect them. Coming also down from the passive transport, it also does cause channel-mediate passive transport, so of course I put those two together. Now coming back up to my graph and coming to the right side, now the plasma membrane, they are selective permeability, they do contribute to vesicles as well. Vesicles do contribute to the selective permeability. Coming up here, it does cause a concentration gradient, and I did the 3 different types of concentration gradient, which is your isotonic solution, hypertonic solution, and your hypotonic solution. And then from there, I did the types, which another type is your electrochemical gradient. Now, the 2 types that fall off the electrochemical gradient is, of course, your osmosis and your simple diffusion, which also you could have added your active transport. I just chose to put it with the passive transport. But other than that, this is my plasma membrane concept map. Thank you.